Hello everyone, how are you? So once again welcome back to Gate Academy Global. So my dear friends, in the last session we have seen the concept of the framing as well as bit stuffing. So we will continue from the last session. I have given you a problem. Okay, I have given you just a simple problem and asked you to find out whether the bit stuffing will happen over here or not. Okay, so let's see the problem. First of all, I have given you a flag pattern that I have given you yesterday is 0 followed by 4 number of ones, and the actual data was 1011101. Okay, so find the transmitted data. Find transmitted data. This I have asked you. Hope you remember. If you have attended the previous session, then you remember this particular things. Yes or no, everyone? So I hope all of you remember this. If you haven't attended last session, then go in the previous lecture and try to attend it. Then only you will be able to know what I am trying to say. Okay, so let's see. So here the flag pattern is given like this. This is the actual data given. Now you have to find out the transmitted data. So you might be thinking, sir, there is no any flag pattern inside the data. So the transmitted data will become same as the actual data, that is 101101. Yes or no? So you might be thinking one of the possible answer that you can give is this. This one will become the transmitted data. But my dear friends, my question is it correct answer? Is it correct answer? So you will be able to feel the answer or the logic, you can say. Answer is nothing but derived from the logic. Okay, so you will be able to feel the logic if you will look upon both the perspective, sender as well as receiver. So let's try to see. Suppose one side there is a sender, another side there is a receiver, and they are connected through this link. Okay, so just try to think about a particular situation. This is the sender and this is the receiver. Okay, and both are using the flag pattern. 0 followed by 4 number of ones. Okay, so this flag pattern is common for the sender as well as receiver, because the things which is common means a protocol or the logic which is known by each and every node. Protocol is nothing but a logic known by each and every node, or you can say the rules that is known by each and every node. So this is the flag pattern which is known by sender as well as receiver. Now I am considering two different situations. Please try to understand what I am trying to say. Suppose the sender has a actual data that is nothing but 10 followed by 4 number of ones. So what you are identifying over here, since this actual data having a flag pattern, so what we basically do, if the flag pattern is 0 followed by 4 number of ones, then according to this what we basically do, insert 0 just after 3 ones. Yes or no? Since there are 0 followed by 4 number of ones, so just insert 0 after 3 ones, or you can say 4 minus 1 ones. Yes or no? So once the sender will start reading, this actual data, so immediately just after the 0 followed by 3 number of ones, what it will do? It will insert 0 over here, and the transmitted data will become what? 10 followed by 1101. So this is nothing but a stop bit. Yes or no? This is nothing but a stop bit. Now this particular transmitted data will be transmitted over the unreliable medium, and it will reach to the receiver. So once the receiver will receive this, that is the 101111 followed by 01. So what is the responsibility of the receiver? The receiver has to remove the stub bit. Yes or no? If this stub bit is inserted by the sender, then it has to be removed by the receiver. Are you getting my point or not? So after reading 0 followed by 1111, what receiver will think? since the receiver is also using the same flag pattern. Since the receiver is also using the same flag pattern, means receiver is also thinking whenever 0 followed by 3 number of ones will be hit, the next bit will be definitely a stop bit. Yes or no? The next bit will be definitely a stop bit. So whenever the 0 followed by triple number of ones will be hit, it will find the next bit as a stop bit and it will remove it, and then it will receive the actual data as 10 followed by 4 number of ones. Yes or no? Because ultimately our target is to deliver the actual data from the sender side to the receiver side. We are implementing a stub bit simply to avoid the flag pattern from the data part. Yes or no? We are simply implementing a stub bit to avoid the flag pattern from the data part. Yes or no? Are you getting my point? So whenever the receiver will receive this particular data, so what it will do? It will scan the inputs from left to right. Means it will scan all the bits from left to right, and whenever 0 followed by triple number of ones will be fetched, definitely the next bit is nothing but a stop bit, and this is understood by this particular flag pattern, because since the flag pattern is 0 followed by 4 number of ones, it means whenever 0 followed by triple number of ones will be hit, the next bit will be always a 0, that is the stop bit. Because the simple rule is insert 0 just after 3 ones. So if the sender is implementing this rule to stop for extra bit, so definitely according to this rule the receiver will also remove the stop bit. Okay, so this point is clear to you, not a problem at all. Now think about the another situation. Second situation. Okay, so suppose the sender have a actual data like this, 10 followed by 11101. Okay, now you have two different options. Since you are thinking, sir, there is no any stop bit in this particular actual data, so please transfer it as it is. So let's try to do that and try to find out the problem that is going to be happen at the receiving end. So since you are thinking, since no flag pattern, this is the first scenario that we are working with. Okay, since no flag pattern in actual data, so transmit it as it is. Okay, as it is. So what will happen once you will transmit it as it is? So definitely the receiver will receive this 0101101. My dear friend, just before this you have received the same pattern. Received the same pattern. Now how the receiver could be able to understand whether whenever there is a 0 followed by 111, whether this bit is a stub bit or the actual data word bit, actual data bits. How the receiver would be able to identify this? How the receiver, because just before the same sequence of bit pattern has been received and the receiver has removed this particular bit. Are you getting my point or not? Same sequence has been received just before, and the receiver has removed this particular bit and received the actual data word, or you can say actual data. The same thing will be applicable in this sequence also. Yes or no? So whenever the receiver is identifying 0 followed by triple number of ones, what it will do? It will remove this and it will receive the actual data as 10 followed by 4 number of ones, which is incorrect. And this thing is showing the sender cannot send this as a transmitted data. Yes or no? Everyone, please answer me. The sender cannot send the same sequence of bits as a transmitted data over the medium, because if you will send same sequence of bits, because you are thinking there is no any flag pattern inside the actual data, so let's transmit this as it is. So what will happen at the receiving end? Whenever it will be received by the receiver will apply the same thing that it has done just before. So after applying the same concept, that is the whenever there is a 0 followed by triple number of ones, next bit is a nothing but a stub bit. So just remove it and receive the actual data. So if the same thing will happen with the same sequence of bits, the wrong data, or you can say incorrect data will be received. Means this possibility is not a feasible way to transmit the data. This is not a feasible or suitable way to transmit the data. So ultimately what we have to do, let's take the next situation. That is the situation number B. Means we have to apply simply the same concept. We need to identify the transmitted data. So how we will identify? Whenever there is a 0 followed by triple number of 1, just stuff 0 over here. Whether the actual data have a flag pattern or not, we are not bothered about this. Whenever 0 followed by 3 number of 1 will be hit, just insert 0. Whether the actual data is containing flag pattern or not, we are not bothered about this. Yes or no? Just stuff 0. So once you will do that, the transmitted data will become 10111001. So this is nothing but a stub bit. So once you will transmit this particular data over the medium, and once this one will be received by the receiver, what the receiver will do? The receiver, looking upon the flag pattern, which is common to both sender and receiver. So looking upon the flag pattern, what the receiver will think, what you will think. If suppose you are at the receiving end, so what you will think? Whenever 0 followed by triple number of ones will be hit, next bit is nothing but a stub bit. So just remove it and then receive the actual data. That is nothing but 101101. Now receiver is able to receive the actual data. Yes or no? Everyone. Now the receiver is able to receive the actual data in a correct way. So this is the correct actual data. So definitely these things will never be followed. The sender will always follow this particular approach. Yes or no? The sender will always follow this particular approach. Got it, everyone? Got it? So even though there does not exist any flag pattern inside the actual data, but still we are inserting what? We are inserting a stub bit. Because if you will not do it over here, if you will not do this at the sender end, then the receiver will receive the incorrect data. Is that clear? Now based on this concept, I am giving you an example. Okay, I am giving you an example. And this example has been asked in GATE 2004. Suppose the question is given like this. Suppose the flag pattern is 0 followed by triple 1. Okay, and actual data is given as 1011101101. And you need to find out two things. Find transmitted data. The GATE can ask the same question in two different ways. Okay, so find the transmitted data. This is the one of the type of question the GATE can ask. The second question the GATE can ask could be find number of stub bit. Okay, number of stub bit. So if you know the concept, then you can answer any kind of question. See here, what is the flag pattern given? 0 followed by triple 1. So looking upon the flag pattern, what we will do? Whenever 0 followed by double 1 will be hit, just insert 0 without looking upon the next bit. Yes or no? So since the flag pattern is this, then what the approach you have to use? Insert 0 after 2 ones without looking upon next bit. Okay, without looking upon next bit. Okay, next bit, whatever the next bit is, we are not bothered about it. whenever inside the data field 0 is followed by double 1, then just insert 0. Okay, so just see over here, so here 0 followed by double 1 is here, so just we will insert 0 over here. Okay, now 0 1 0 and 1, so here again we are identifying 0 followed by double 1, so simply we will stuff 0 over here. So the number of stub bits are how much? 2. And once you will try to find out the transmitted data, this one will become 1 0 double 1 0, this is the stub bit, and again 0 1 1 0 0 1, and this is also a stub bit. So this one will become the transmitted data. So without looking upon the next bit, what is the next bit is? Whenever you are identifying 0 followed by double 1, just stub 0. Whenever you are identifying 0 followed by double 1, just stub 0. Without bothering about what is the next bit given. Are you getting my point or not? And these things I am writing from this particular concept. We don't need to care about what is the next bit is. Whenever we are reading 0 followed by n minus 1 number of ones, just insert 0. Just insert 0 without bothering about the next bit given inside the actual data. Is that clear? So the total number of stub bit will be 2, and this one will become the transmitted data. So this is all about the framing and bit stuffing. So I have solved like 2004 problem. Okay, so you can just look upon the GATE previous year questions. There is another question that has been asked in GATE 2015. GATE 2015, there is another questions which is based on framing and bit stuffing, that you can see. If you have a workbook or if you have a GATE previous year question bank, then you can look over there. So till now only 2 questions has been asked from this particular concept. One in the year of 2004 and another in the year of GATE 2015. So if you don't have a workbook or the GATE previous year question bank, then just buy it. My dear friends, without having a proper book, we cannot go in the journey of preparation. Are you getting my point? Because it will give you a lot of idea what kind of questions the GATE usually asks in every year, which are the topic from where the GATE basically frequently asks the question. Okay, and which are the topics from where the GATE frequently asks the questions. So the previous year book basically give us a lot of idea, and once we will start solving it, and once we will solve 80 to 90% of all the previous year question, it will give us a lot of confidence, and that confidence only help us to bring AIR under 100. AIR under 100. Okay, so what you need to do, you have to only keep a previous year question bank, otherwise I am with you. As soon as I will complete the topic, I will try to solve as maximum problems as possible. So you don't need to worry about it. What you have to do, you have to attend the lecture one by one properly, and you have to follow all the GATE previous year questions. And whenever I will say you to read this particular topic from the book, please try to follow it. Because being a teacher or being a part of GATE Academy or any organization, I can't give you 100% content free on the YouTube channel. This is the fact. There is nothing to hide. Okay, there is nothing to hide. This is the fact. So definitely, if I am not able to give you the 100% content, then definitely I will give you at least 80% content. 80 to 85% content definitely I will give you. But for the remaining 20%, you have to work a little bit hard. Okay, so for the remaining 20%, if I am not able to deliver, then I will refer you the book as well as the topic also. So not to worry, only you have to be consistent. You have to be consistent throughout the journey, because this is the journey of 8 to 10 months. If you will remain constant in this journey, then only you can expect better thing from your life. Otherwise, you don't have any right to expect any better life in future. Yes or no? Everyone, just tell me the answer. Are you getting my point or not? So just be with me for the next 8 to 10
journey with positive attitude, with strong mind setup. Just be with me. I will just deliver you almost 80% content of the computer network, and please try to follow the instructions, because wherever you will be failed to follow, I cannot assure you that you can have a better future ahead. Are you getting my point or not? So as I told you, buy the GATE previous year book. It is available online. If you want, you can book through our organization, that is the GATE Academy. If you want, okay, not a problem at all. Buy from anywhere. This is also available in GATE Academy platform. So just visit to the www.gateacademy.co.in and you can place order over there. And the best part of the GATE previous year question bank in our platform is all the solutions has been given by faculty, not by the content developer. Means the accuracy level of the solution is very high. I cannot say 100% accuracy, but the accuracy level is very high in comparison to the other platform. Okay, so this is all about the framing and beta stuffing. Now we are moving ahead towards the flow control protocol. So let's see the flow control protocol. As I told you, every year one question is asked from this particular topic. Okay, flow control protocol. Okay, protocols. So first of all, try to understand the syllabus inside the flow control protocol. So in flow control protocol, basically we have to deal with two different kind of protocol. One is like stop and wait, and second one is sliding window. Okay, sliding window. Inside the sliding window, there are two topics that we have to deal with. First one is the go back and the second one is the selective repeat protocol. Okay, so basically these are the topic that we have to deal with. And as I told you, every year one question is asked from this particular topic. Means you can just mark it triple star. Means note that, okay, every year there is one question from this topic, okay, from this topic. So one question generally have a 2 marks. So my dear friends, only studying this particular topic, you can secure 2 marks in your GATE exam. So just be with me in the next 3 days. In the next 3 days, I will give you 2 marks in your scorecard. I am telling you, all of you. I am just telling you, just be with me. In the next 3 days, I will bring 2 marks in your scorecard. Sorry. Okay. So see, this is our first time experience that we are delivering our lectures in English, and I am trying my best to give you the best content of the computer network in English. Okay, so just don't worry, because whenever we are in hurry, something unusual things happens. Okay, so you can just you just try to understand the feeling also. Whenever we are trying to interacting or we are trying to deliver the content in English, sometimes try to understand the feeling, because there are some words which does not comes in our mind frequently. Okay, so in that situation you have to also understand our feeling. Okay, so we have to be connected in anyways. Okay, so let's start with the flow control protocol. So before starting stop and wait and sliding window protocol, there are some parameters that we have to understand. So inside the flow control protocol, there are some delays that we have to deal with. Okay, so let's see, or you can say some parameter associated with the flow control protocol. Okay, so there are some
some parameters associated with flow control protocol, with flow control protocols. Okay, so please try to understand. Suppose this is the sender and this one is the receiver, and they are connected through this link. Okay, through this link. Now this is the sender and this one is receiver, and from here we are representing the timeline. This is nothing but a timeline. Okay, this is nothing but a timeline representing. Timeline means from here we are trying to represent a time. Okay, so suppose this sender have a frame to transmit means at time t is equal to 0, this frame is residing inside the buffer of sender. Means suppose a frame is already ready to move, means definitely your frame will be staying at your RAM in your computer, a buffer, yes or no. So whenever you are trying to send a data frame through your computer, definitely it is ready to move, means presently it is staying in your buffer, yes or no, in your buffer. Are you getting my point or not? So the same situation we are considering over here. So at the time t is equal to 0, this particular frame is staying at the buffer of sender. So if this is the frame, then this frame will have some size. So just imagine the size of this particular frame is what? L bits. How much? L bits. Okay. So here we have considered the size of the frame is L bits. Now we need to actually identify how much time the sender will take to drop this frame from the buffer to the medium. So just try to imagine this particular situation. Suppose this is the computer, and below this there is a buffer of computer, and above this there is a wired medium. Just try to imagine a situation. Above it there is a wire medium, and below there is a buffer inside the sender, and this is the frame which is currently available inside the buffer. So basically we are trying to find out how much this particular frame will take to come from buffer to the medium, and this is nothing but transmission time of single frame. This is called transmission time of single frame, means time taken by a single frame to come from buffer to medium. Are you getting my point or not? So if you know the frame size and if the transmission rate of the sender is given, then you can easily calculate the transmission time of this particular frame. If the transmission rate of the sender is given, then we can easily calculate how much time this frame will take to come from buffer to medium, that is the link, yes or no. So this is called transmission time of the frame. So TF is nothing but, so here TF basically representing, T means time, F means frame. Okay, so TF basically represent transmission time of single frame, okay, transmission time of single frame. Is that clear everyone? So how you can calculate it? If you know the frame size and if the transmission rate is given, okay, the transmission rate is given as suppose here the transmission rate, whenever I am writing rate means it is nothing but transmission rate, okay, transmission rate is given as RBPS. What is the meaning of BPS? Bit per second. So whenever I am writing rate is equal to RBPS. So BPS basically represent bits per second. So this is nothing but like a velocity, na?
like a velocity. So if the frame size is known, velocity is known, means if the distance is known, velocity is known, you can calculate the time. Means if the distance of 2 point is known and the velocity is known, you can find out the time taken by a bus to deliver from one point to the another point. Yes or no? Easily we can calculate. We have already learned these things in our 8th class. Yes or no? Everyone, is that clear? So if the transmission rate is known and the size of the frame is known, then we can easily calculate the transmission time of the frame. And how you can calculate? So TF will become length upon R. So definitely this length is given in bits and R is also given in, suppose, bits per second. So definitely bits will be cancelled out and L by R, this one will just represent in second. Are you getting my point or not? Are you getting my point or not? So this is nothing but the transmission time of a frame. So transmission time means time taken by a single frame to reach or to drop into the medium from the buffer. To drop into the medium from the buffer of sender or receiver, anything you can say. Are you getting my point, everyone? So is that clear? So in a simple way, how you can define it? Time taken by single frame, okay? Single frame to drop into link. Either you can say link, channel or medium, whatever you can say. To drop into link from buffer of node, because that particular node can be a sender or receiver, and that's why I'm writing a common name, that is the node. Okay, so suppose after TF time this particular frame has reached to the channel. So just try to imagine a situation like this. Okay, this one. So this frame is nothing but the sequence of bits. Yes or no? Means in this entire frame there will be a bits filled. Yes or no? Yes or no? So my dear friends, whenever this frame will come to the medium, it will be converted into a signal. Signal means electromagnetic wave. Are you getting my point or not? Once this particular frame will come to the medium, definitely inside the medium only the signal can travel, and signal is nothing but a electromagnetic wave. And what is the general velocities of the electromagnetic wave? Means electromagnetic wave means it is ultimately a wave, and generally the wave travel with the velocity of light. So the speed of the signal is nothing but equivalent to the velocity of light, or you can say the speed of light. So whenever you will try to solve any questions, and whenever the velocity is given or the speed of the signal is given, always look upon that particular speed. It will be always equivalent to the speed of light. Whenever you will try to solve any questions, the speed of the signal will be given almost equivalent to the speed of light. Okay, I will show you some of the GATE previous year questions, and there you can verify these things. So signal is nothing but a wave, and the velocity of wave is always equivalent to the velocity of light. So this is the part of another thing what we are trying to find out over here. Please try to understand. So see over here, whenever this particular frame will drop into the medium, it will be converted into a signal. So this is the first bit, second bit, and dot dot dot, this one is the last bit. This one is the last bit of signal. Yes or no? So from here to here, all the values are bits, means bits converted into a signal. Yes or no? Inside the frame there is a sequence of bits. Out of this sequence of bits, this is the last bit. So how much time this particular last bit will take to come from here to here? This is called propagation time, or sometimes we say the propagation delay. Means just try to imagine a situation how I have represented the diagram. Okay, so just think about this particular last bit. My dear friends, if this particular last bit will reach over here,
it means entire frame will get delivered to the receiver. Yes or no?
If this particular last bit is reached over here, it means the entire frame has been delivered to the receiver. Yes or no? Yes or no? Means this frame is taking how much time? TP time to deliver into the receiver. Got it? Everyone. So how you can define the propagation delay? Because I am defining the propagation delay with respect to the this single bit. So just think about it. The time taken by a single bit to reach from one point to the another point. Okay. So this diagram in this particular link, how you can think about? You can think like this. This is the one end point and this is the another one end point of the single link, of the same link. Yes or no? So the time taken by a single bit to reach from one point to the another point is called the propagation delay. So how we can define the propagation delay? So just see over here. So TP is nothing but propagation delay. Or delay, sometimes you can say also a propagation time. So how you can define the propagation time? Time taken by single bit to reach from one point to another point of the same link, okay, same link. How you can calculate the TP? So my dear friends, if distance between sender and receiver is known, suppose this is the d kilometer, and if the speed of the signal is given, then you can easily find out the TP. Yes or no? So how you can calculate the TP? The TP will be calculated like this. So TP is nothing but distance upon speed. Yes or no? Where d is the distance between two connecting node and s is equal to speed of signal, and you can note it down. Speed of signal remains equivalent to light. Okay. So how much time this particular frame is taking to deliver from sender to the receiver? So at the t is equal to 0, the frame was inside the buffer of sender. So after the TF time, it has come to the link, and after TP time, it has reached to the receiver. So here after t is equal to TF plus TP time, the entire frame is delivered to the receiver. Yes or no? The entire frame is delivered to the receiver. So this is the total time taken by this frame to reach from S to R, sender to receiver successfully. Yes or no? This is the total time taken by a single frame to reach from sender to receiver successfully. So my dear friends, when the receiver will receive the frame, what it will do? It will definitely give the confirmation of this successful delivery, because there might be a possibility the frame sent by the sender could be lost in between the network. Suppose if you are sending one bus from like Delhi to Chandigarh, so there might be a possibility that particular bus has involved in accident, and that's why it will be never able to reach over there. So it is always a responsibility of Chandigarh controller. Whenever it will receive the bus from coming from Delhi, it has to acknowledge for each and every bus. It has to acknowledge each and every bus, so that whenever any bus would get missing, the Delhi controller would be able to retransmit the same bus. Yes or no? Yes or no? So in the data communication, we are going to apply the same concept. In the data communication also, we are going to apply the same concept. So whenever the sender is sending a frame to the receiver, definitely it will also expect for the acknowledgement. It will always expect for the acknowledgement. And only after getting the acknowledgement, the sender will be able to confirm that the frame it has sent has been delivered successfully. So the successful delivery of the frame can be made whenever acknowledgement corresponding to that frame will be received by the sender. Are you getting my point or not? The frame will be delivered successfully if and only if the sender will receive the acknowledgement corresponding to that particular frame. So definitely, once the receiver will receive the frame, what it will do? It will create the acknowledgement frame. So suppose this is the acknowledgement frame created by the receiver. This is the acknowledgement frame created by the receiver. So my dear friends, whenever you are creating any acknowledgement frame, then definitely it has to be created after processing this particular frame. Means suppose if you are sending any bus from Delhi to Chandigarh. So once the Chandigarh controller will receive the bus, it will create a acknowledgement frame, or you can say acknowledgement like car. Yes or no? Acknowledgement car. And how they will be able to create it? Looking upon the bus number come from Delhi to Chandigarh, it will write each and everything. The bus number, driver name, their code, entry, everything it will note it down inside the acknowledgement frame. So that whenever this acknowledgement car will go back to the Delhi controller would be able to know, okay, this acknowledgement is coming from bus number 1. Because the Delhi controller is not only sending a single bus, it is sending many buses. So definitely it has to receive the acknowledgement corresponding to each buses. So the different bus will have a different bus number. Yes or no? So looking upon the bus number inside the acknowledgement frame, the controller of Delhi will be able to identify, okay, this is the acknowledgement for this particular bus. So to identify a particular bus which has been delivered successfully, the frame or the acknowledgement car, or you can say bus, should have a unique information, and that information can be gained only through the incoming bus, or you can say incoming frame. So my dear friends, whenever you are creating an acknowledgement frame, definitely like some information should be extracted from this particular frame. So to extract the information from this particular frame and creating acknowledgement frame, in between this there will be a some time consumed. Yes or no? The some time will be involved over there, because you are reading entire content of the frame and then you are creating a acknowledgement frame. Yes or no? You are reading entire content of the frame and then according to that you are creating a acknowledgement frame. So there also involves some time to do this, and this is called processing time. T pro means processing. Pro means processing. T means time. So processing time means processing a particular frame and creating a acknowledgement frame. So it will involve some time. This is called the processing time. So how you can define the processing time over here? So you can define processing time like this. So this is nothing but processing time
processing time, and how you can define it. Okay, processing received frame and creating acknowledgement frame involves some time.
That is called the processing time. So after processing this particular frame, the receiver will create this acknowledgement frame.
So we are saying this is the acknowledgement frame. So you can indicate it L of ACK. So L means frame length, ACK means acknowledgement frame length. Okay. So definitely, if this frame have some size, so the receiver will also take to deliver this frame into the medium. So this is nothing but the transmission time of the acknowledgement frame. Yes or no? The transmission time of the acknowledgement frame. So after T of ACK, this frame will be dropped into the medium, and this is the last bit of frame, and the time taken by this bit to reach from one point to the another point is called the TP. So after TP time, here the acknowledgement frame will be received.
So once the sender will receive this particular acknowledgement frame, then only the sender will be able to confirm that the frame that it has sent has been delivered successfully. So here we are trying to find out how much time a single frame will take to deliver from sender to receiver successfully. So that is nothing but the TF, TP, T processing, T of ACK, and then TP. Yes or no? So here we are going to find out
total time involves by a single frame to deliver from sender to receiver successfully will be what? So TF plus TP. Okay, and then after this time the frame will be received by the receiver, then the receiver will do the processing over the frame and will create the acknowledgement frame, and then once the acknowledgement frame will be created, the acknowledgement frame will be transmitted over the medium. So it will take T of ACK time, and then this frame will be transmitted over the medium, and that will take the TP time. So here since the size of acknowledgement frame, see, this is just a confirmation frame. Acknowledgement frame is not containing any data. As the name indicates, this is just a confirmation frame. Suppose you are sending 1,000 passenger in a train from Kolkata to Delhi. So to acknowledge this, that this train has been reached to Delhi, the Delhi controller send another train to Kolkata to acknowledge this? No. Only one passenger is sufficient to acknowledge this information to the Kolkata controller. Yes or no? If from the Kolkata, if you are dispatching 1,000 number of passenger in a single train, so to give this information, we don't need to send 1,000 number of passenger from Delhi to Kolkata. Only one passenger is sufficient to acknowledge this particular information to the Kolkata controller. The same thing is happening over here. Acknowledgement frame is not a communicating frame. It is just a confirmation frame. So generally the size of, if size of acknowledgement frame is tending to 0 means very less. Whenever I am saying tending to 0 means very less. So if the size of acknowledgement frame is very less, then T of ACK will also tend to 0. Again, if you will think about the processing time, generally the processing times are very small.
very small. So sometimes you can also ignore the processing time also. So inside the question these informations will be given. You no need to worry about this. Generally by the rules, if you will try to calculate the total time taken by a single frame to successfully deliver from sender to receiver, this is the this. That is the this. Okay. But inside the question, if the information will be given as like the acknowledgement frame, transmission time of the acknowledgement frame is negligible, as well as the processing time is also negligible. So what you can do? Out of this particular total time, you can make 0 to this and this. And these things you can only do if it is given inside the question. So the every information will be given inside the question. There are some questions where you need to consider the transmission time of the acknowledgement as well as the processing delay, or you can say the processing time. So everything will be given inside the question. So in this lecture we have learned about some of the parameters associated with the flow control protocol. First one is transmission time of a frame, second one is propagation delay, third one is processing time,